Welcome to another session of Ebenezer Gate coaching classes. This is a numerical aptitude type problem for 2 marks. An AC voltage source V is 10 sin T is applied to the following network. Assume that R1 is 3 kilo, R2 is 6 kilo, R3 is 9 kilo, and that the diode is ideal. V is 10 sin T, RMS current IRMS through the diode. So it's the half-wave rectifier because the diode conducts only during the positive half cycle, and during the negative half cycle it is going to be off. So if if the current is Im sin omega t, then RMS current is for half-wave rectifier is Im by 2. I think this is known to all. How do you find the RMS? What is RMS? RMS is root mean square. So what is I? It is Im sin omega t for t from 0 to t by 2 and 0 from t by 2 to t. So square of this is Im squared sin square omega t. Mean of that is 1 by t, 1 by t integral 0 to t by 2 Im squared sin squared omega t dt. So then you have to find the root of this. So what is that? What is Im squared sin squared omega t? Im squared sin squared omega t is Im squared sin squared theta is 1 minus cos 2 theta by 2. 1 minus cos 2 omega t by 2. Let integrate it with respect to dt from 0 to t by 2. And we have to divide the whole bracket. So if you integrate it, we will get Im squared cos to omega t. If you integrate it, you will get sin to omega t. And if you put limit t by 2 at 0, it is 0. So that term will go. You will have only Im squared by 2 times t. T is t by 2 into 1 by t. So t and t will get cancelled. So it is Im squared by 4. And root mean squared, this mean of square, root of mean of squared is Im squared by 4. Root of that it is Im by 2. So IRMS is Im by 2. Now let us find out what is Im. Now here we will apply symmetry because this point A, point B, point D and point F are similar. Okay, point A it is going through R1 to B, A it is going through R1 to D, A is going through via R1 to F. Same way it is going. So whatever is happening, whatever is the voltage here will be the voltage at T and will be the voltage at F. So all three currents will be same. So if the current going here is I, the current is I here, then the current going here will be I by 3, current going here will be I by 3, and the current going here will be I by 3. Okay. Similarly, from this point, whether if it has to go to C or G, it is the same. C and G are similar because after that R3 goes to H. Here from G R3 it goes to H. From uh, from C and G is a similar point. So whatever voltage is there in C will be in G also. So the current here again will be divided. You're having a current I by 3 here. So when it goes to R2, it will be I by 3 by 2, that is I by 6. And here also it will be I by 6. Now again, similarly from here it will go I3 will get divided into, here it will get I by 6. And this I by 6 and this I by 6 will get combined and you get I by 3. Okay. So you can take any three. You can take this, then you can take this, you can take this, add the voltages, and that is the applied voltage. So let's just assume the applied voltage is V. So V is equal to I by 3 into R1 plus I by 6 into R2 plus I again I by 6 plus I by 6 is I by 3 into R3. Okay, one R1 you take, one R2 you take, R3. Anything you can take. You can take this A to D, D to C, C to H, or A to F, F to G, G to H. Any place you go, you get I by 3 and one R1, I by 3 into R1. Then next I by 3 is divided by 2, I by 6 into R2. Then I by 6 and I by 6 gets combined into I by 3 at R3, I by 3 into R. R1 is given as 3K, R2 is given as 6K, R3 is given as 9K. So if you multiply it here, you get 3 into I. So here it I by 3 into 3, that is I by 6 into 6, it is I, and I by 3 into 9 is 3I. So V is actually 5I, or I is actually V by 5. What is V? V is 10 sin t, so I is actually 10 by 2, which is 2 sin t. 2 sin t during the positive half and 0 during the negative half. And RMS is going to be Im by 2, which is 2 by 2 or plus 1 amps. 1 milliamp. So because everything is in kilo, current is in milliamps. So answer is 1. Thank you. God bless you.